Okay, thanks, Gemma. Yeah, welcome to BGC and Cambio Earth's 2024 R&D Symposium. My name is Matt Lotto. I'm a geotechnical engineer and have been involved in R&D leadership at BGC for about the past 6 years. This is our second annual R&D Symposium. It's an opportunity for us to open the doors into our innovation program and share some of our most significant developments from the past year, and most importantly, the amazing people behind the work. As this is a virtual event with people joining from around the world to talk about the applied earth sciences, I would like to acknowledge that I'm joining from Ottawa, Ontario, where I live and work, located on the traditional, ancestral, and unceded territory of the Anishinaabe Algonquin Nation. I invite folks to share in the chat where they're joining us from today. Investment in innovation is a strategic priority for BGC and Cambio Earth. Innovation is needed for us to achieve our 2025 big goal of being globally recognized for our leadership in solving the world's most critical applied earth science challenges. In the past 2 years, BGC has invested nearly $10 million in over 150 R&D projects, and over 300 BGC staff have contributed to those projects. Equitable access to R&D time and resources is critically important, and in 2023, the last year we have full data for, over 50% of the projects were led by women, accounting for 46% of the total expenditure. At BGC and Cambio Earth, we believe investing in innovation supports better solutions for our clients, increasing efficiency and quality, and supporting the lifelong learning of employees. Before jumping into our first talk, I'd like to give a big thanks to the amazing Dr. Gemma Bullard for leading the organization of this event. Your hard work is really appreciated, and I'm really excited for today. Gemma was supported by Lauren Hutchison, BGC's innovation lead, Dr. Lucas Aronson, BGC's cryology team lead, and Melissa Murray, BGC's marketing communications team lead. Today should be fun, and as you listen in, if you have a question, please drop it in the Q&A channel or leave a comment in the chat. If there's a project you want to learn more about or an idea you want to collaborate with BGC or Cambio Earth on, please reach out. We want to hear from you. As you'll see today, we love what we do, and we want to share our work with the world. Now for the fun part, why we're all here today. Our first talk today is from Dr. Jean Hutchison. We're incredibly fortunate to have Jean join us today and share her thoughts on the importance of research, collaboration between industry and academia. Jean's engineering and academic work spans more than 40 years in nearly every corner of the earth. Instead of listing Jean's awards, which are well-deserving and plentiful, I'm going to put them in the chat here. All right, there we go. I wanted to give a more personal introduction. I've known Jean for over 20 years, and she's played many amazing roles in my life, from teacher, supervisor, coach, mentor, friend, and landlord. I'm quite certain she only regrets one of those. Jean is incredibly thoughtful and generous. I've always been able to rely on her for advice, talk through a challenge, or discuss a new opportunity. Jean has opened up numerous doors for me and is a big reason I'm here at BGC and in this role today. She has an amazing vision for the future of geotechnical engineering and is a perfect person to kick off this year's symposium. Thank you for being with us here today, Jean, and I look forward to your talk.
All right, there we go. Can you hear me okay?
We sure can.
Thank you very much. Sorry, there's a lot of things coming in here on my screen. So we did practice this. It doesn't look like we did, but we did practice this. Okay. Thank you very much. So I'm very delighted to be part of this presentation today, and also to be introduced by you, Matt, given our long history of working together. And I have learned more from you than you have learned from me, I think. So thank you for all of your contributions to my career over the years. And so today I was asked to sort of reflect on the value of university and industry collaborations. And so I will do so. I'm not speaking very much at all about my own personal research, more about the broader perspective. But as Matt said, I'm delighted to speak with anybody about what we've worked on over the years. So first off, I would like to acknowledge the land that I live and work on, which is here in Kingston, Ontario, land of the Anishinaabe and Haudenosaunee peoples who have been stewards for this land over time immemorial. And my hope is by the work that we're doing, we continue to reflect on and support continued collaboration with Indigenous peoples on stewardship and the future of our lands. The image I'm showing you here is from an artist local to Kingston called Mance Granberg, Saint-Aubin, who is Indigenous. And they asked me to share the message of this painting, which is that the stewardship of our waters and our lands is a key part of our future sustainability as humans and creatures on our earth, and also representing the value in the center of the painting of the bear as a representative of those important initiatives for his peoples. If you're interested in Mance's work, he has a webpage on Facebook, MNSA, if you want to have a look. Beautiful work in all sorts of styles that Mance does. So first off, I'd just like to give you a general outline of the talk in terms of R&D partnerships. First, the motivations. Secondly, my experiences. And third, measures of success. And I'd like to address this from the perspective both of my career as an academic, but also my collaborations with industry and government over my career. So hopefully I can address this from those multiple perspectives as well. So in terms of motivations for R&D collaborations, if we have a look at the main federal funding agency in Canada, which is often where we can spearhead some of these industrial collaborations, NSERC, they list a series of 6 points related to why we should collaborate on R&D between academia, industry, and government. Their order of these points is a little different than mine, but in any case, the first thing on the list is to generate new knowledge and or technology to address complex challenges. And I suspect that everybody on the call today is already very, very aware of that, and that's why you're attending. From the perspective of both the production of an academic, but also the contributions, training of new researchers in areas that are important is a key component of these kinds of collaborations. We want to train people who are aware of the issues in industry and able to apply what they've learned to those considerations as well. We draw on diverse perspectives and skill sets, and that is required to accelerate the translation and the application of the research results. Again, over my career, I've seen a greater and greater and very important emphasis on application of research into industry. When I first started, it was very much lab-based, white lab coats in the lab, and not really much consideration of how that was translating out into industry. And that's changed much for the better. Also, perspectives that are very important from the funding agencies and some organizations are the creation of economic, environmental, and societal benefits. From NSERC's perspective, contributions to Canada's long-term competitiveness, and also the support of public policy. Two other main considerations for this type of grant that they provide in collaboration with industry is that we must demonstrate that we have equity, diversity, and inclusivity built in to the design of the research programs, to the collaborations, to the training and mentorship and professional development opportunities that are provided to the students and trainees. And when we're looking at this from the perspective of working with industry, we need to make sure that both in the academic setting and the industry setting, we're addressing these important initiatives and perspectives. Also, recently in Canada, there's been a new set of national security guidelines developed, considering some of the global concerns these days. And so now there are guidelines on the kinds of research partnerships that we can engage in with some countries around the world. And so that's probably more for the academics in the crowd who would already be aware of this, but this is another way that our research environment is changing over these times. So what do industrial government partners bring to the collaboration? And everybody on the call who comes from either of those two organizations is probably aware of many of these components. Normally, in the past, again, we were thinking mostly about the bottom points, the points about support, whether it was funding in terms of dollars, in terms of time, and that is a very significant component when there's a very strong collaboration. There's a lot of time involved in keeping the collaboration going. And then also in terms of access to facilities or data or samples or any other things that come from the industrial partners. Those are all sort of more formal ways of recognizing and engaging in support. But probably equally as important from the perspective of what the academics gain from those relationships is the experience and knowledge that comes from the people who engage with you from industry and government. They have a wealth of knowledge, a wealth of awareness of some of the complex challenges that need to be addressed. And so that's a very important contribution and something that needs to be encouraged throughout one of these collaborative relationships. Partnership in the development of methods, analysis methods, management of research is also a key part of what the industrial and government partners will bring. Site access and information training. I can't emphasize that enough. Access to sites where there are the challenges we're trying to address is a very difficult, often process to allow academics and students onto site, but it's a key part of the work we do and a key part of the training we do. And again, access to data, whether it's a collaborative collection of data or access to existing information, that's a key part as well. It costs a lot for us to develop data sets. And so if we can benefit from data sets that have already been collected, that gives us a huge advantage in terms of progressing the research. And then at the bottom of the list are the implementation trials and the critical evaluation of the effectiveness of those trials being done by all the partners to the collaboration. And without all of these things, the collaborations are much less effective and efficient. So a couple of important considerations when you're engaging in one of these collaborative projects. The first is what intellectual property, what knowledge, what data sets, what processes are the partners bringing into the agreement, and that's all the partners. So we have to establish what is being brought into the agreement so that that's clear, and then also a discussion about what you expect will be developed, who will own what is developed in the future, who can access what is developed in terms of use and further development. Is there potential for commercialization? These are all really important considerations for everybody in the agreement. And where I've seen challenges in the past is where this conversation isn't necessarily engaged in as completely as it should be. People may not anticipate what might happen. And so these are a really important part of the early stage discussion. Publications for academics, our CVs and our grant application success relies very heavily on publications. Sometimes there's confidential information. Sometimes you can't name a site, or there may be a certain time period in which the publications are embargoed. Another important consideration is the co-authorship. Generally, I work with a variety of people, and generally all people are listed on the paper that we publish. But I think in a lot of circumstances, the recognition of how important those publications are on the academic side may not be as high as it needs to be. The other thing about that is that when we have confidential information, if there's something where there's a research program that can be engaged in, but the results really need to be kept confidential for some period of time, that changes the agreements you might engage in with academics from being more of a research grant or research program into a research contract. And so in sort of my world, a research contract is something where there's not necessarily that obligation to publish or to relay information. So the difference between a grant and a contract is actually fairly significant from sort of my side of the table. So my experience in R&D collaborations. First off, I've worked with many, many amazing people, including Matt, who you heard from at the beginning. He and many others on this list have been a key part of what I've done over the years. The three main projects in recent years that I've worked on are shown on this slide. So the main one on the left is the Railway Ground Hazard Research Program, which is an NSERC Alliance grant in collaboration with CN Rail and CPKC. And you can see the list of names of students who have completed or completed very recently on this project. And if you are familiar with some of these folks, many of them actually ended up working with BGC in the end. And so you'll probably recognize a number of these names. This was in collaboration with the University of Alberta as well as Transport Canada through this program. From my perspective, a really phenomenal program. It's lasted for almost 20 years with all these partners and been, I think, a big success. There's also two other projects I'm working on at the moment, one being a fragmental rockfall modeling program using physics engines to simulate fragmental rockfalls. And that's in collaboration with professors Wortman and Olson in University of Washington and Oregon. And that is funded by the US Federal Transportation Pooled Fund and 10 of the departments of transportations in the US. And then the Linear Infrastructure Network Resilience Project that Jack Park is undertaking, and that's in collaboration with BGC through a MyTax grant. But as you may see from this, there are an enormous number of exceptional people that I've had the privilege of working with, but there's also in all of these cases, industrial or collaborators, and they've been a key part of this work. So in my early career, just a few slides to show you what I learned early career and how that sort of translated through into the research collaborations that I've engaged in. So finished my PhD in 1992, and during my PhD, I implemented a cable bolt instrumentation program at a small scale, sorry, not a small scale, at Ansel Mine in Rouyn-Noranda, Quebec, a very high grade copper sulfide mine. You can see a young me here on the left with my instrumentation ready to go underground. And then you can see Veronique Filman, who was my advisor at the mine and is now a senior mining advisor with Agnico Eagle Mines, so a very important mentor early on. And then during that same time, a project funded by Canada for International Development with Everett Hook, who was my PhD supervisor. And during this project, I spent 2 periods of time in Zimbabwe working on evaluating ground support for small-scale chromite mines on the Great Dyke in Zimbabwe. And also at that time, a fellow graduate student, and then my husband for 33 years, Mark Diederichs, was also part of that project. Bumping around the heart of Zimbabwe in a Land Rover brought us very close together, if I put it that way. So what I learned from this was, at the very beginning, thoughts about instrumentation program design and implementation, and the importance of redundancy and resilience. So we had many instruments that were redundant in this environment. Many failed in this environment, and so this was a key part of my learning. In terms of the project in Zimbabwe, the value of an excellent team and mentorship, but also listening to everyone within the organization. So the picture that's sort of behind that bubble on the top right is me talking to one of the small scale chromite miners in Zimbabwe whose experience was with the mining, no formal education of any sort. And he'd figured out many of the things that were really critical to keeping those very small scale mines stable. So listening to everybody is a really important component. That then led to me working for a period of time with Dr. Hook through the completion of the project that led to the book Support of Underground Excavations in Hard Rock. That was research funding for my PhD and many other students, collaborative between the 3 universities of Toronto, Laurentian, and Queen's with the professors' names you see on the book. That also led to what are now all of the rock science software packages that were written by graduate students during that time, and I wrote the early stage manuals for those. That also led to, in my case, publishing a paper and giving a paper at the Rock Support Conference in Sudbury that was sort of the wrap-up conference for this whole project. At that conference, there was a heated discussion about cable bolts, which had been my PhD subject. The academics were talking about small-scale grout testing in the lab, and the practitioners were talking about cable bolts that were being left stripped, hanging from the backs and walls of excavations. And never the twain shall meet during that conversation. So out of that conversation arose another project that became very influential on my career. But first, the lessons I learned were the value of clear and concise communication. If any of you knew Dr. Hook, he was very much a master of clear and concise communication and pitching that at all appropriate levels, making sure that it could be understood by whomever you were communicating to. And then in terms of the additional learning, the application of theoretical research findings takes a lot of work and collaboration, hence that conversation during the Rock Support Conference. So that then led to a project looking at implementation, design, monitoring of cable bolts in many, many mines. We visited over 50 mines in Canada, the States, Australia, and Papua New Guinea over the years of 1993, 1994. And here's a variety of pictures from some of those site visits. This led to the publication of the book Cable Bolting in Underground Mines by myself and Mark. And so what I learned from this was the incredible value of site access, data provision, and discussions with those in the real world. And you saw that as one of the top points in my findings from collaborative research. But also that diverse thinking leads to significantly better outcomes. So as part of this project, we spent some time at some mines in Papua New Guinea, and I went off and talked to the miners who were installing the cable bolts, and they explained to me why they were doing some of the things they were. They were brand new ideas that no one else on the other 50 mines had talked about. And if we hadn't had the opportunity to talk to those miners, we would not have been able to incorporate what we did into this book and into the value of circular thinking, where you have feedback loops for assessment and design. So those are some of my early career learnings that I think have really informed how I approach collaborative research from then on. So really critical is, what's the question? What is the motivation for the research? What are you trying to address? You need to have a mutual understanding of the challenges, the opportunities, and the development of solutions. You need to listen to people working at all levels of the organization. And then some new thoughts here: assessment of speculative methods or ideas. Some succeed, some fail. And I think you have to be very aware of the early exit, where someone says, well, that didn't work after one trial, and it gets thrown away. And I've seen that many times in my careers. Oftentimes, things take a while before they're truly a success. A case in point through the Railway Ground Hazard Research Program was early work with the shape accelerators that we now see quite often deployed in monitoring programs. Those were derived from motion picture capture technologies. And the first few trials that Michael Hendry worked through were really not field ready at all. But because we were on a research program, we could keep working on them, and now many people are using them. So that development of field ready methods is a really important component. And then finally, that development of technically focused, highly qualified personnel. That's the sort of academic speak for the people that we train, and they've had exposure to real world issues is a key part of the success. So I've spoken a couple of times about the Canadian Railway Ground Hazard Research Program. That has been the most influential research program in my career. It's been funded by CN and CP, as well as NSERC, with partners listed here, and the industry connectors with BGC and with Clone, Cripp and Berger over the years. So a very influential part of my career in terms of looking at rock slope programs, ground hazard problems on the railways. This lists some of the students who've worked with me over the years. And the reason I'm including this again is to show you the variety of projects that people have been able to work on because of access to these sites, because of the opportunity to collect data over a sustained and long-term period. As I mentioned, this is in the fourth phase, so almost 20 years of research collaboration with all the folks that you saw on the previous slide and many more over the years. Out of this, at Queen's, 55 different people have been trained, and you can see on the inset where they've gone. More than 3/4 have gone to consulting and industry, and I expect a number of the people who are still listed as graduate students will likely end up in consulting and industry as well. But we also have several faculty members who carry on with related research. So measuring success, this is the final part of my remarks today. How do we measure the success of these collaborations? So a lot of what I've been talking about is my personal perspective, but we need to sort of think about this on a bigger framework so that people on this call hopefully continue with or newly engage with these type of collaborations. So the best practices that I've observed are regular meetings. So I know it takes time out of a consultant's day or a person at a site's day or to attend meetings. But when we do have regular meetings, we can address the technical issues that are arising or that we're considering in the collaborative research program. And the railway team, which you see on the bottom right from this is the meeting last year, we meet on a monthly basis and have done for almost 20 years for an hour and a half. So that's a significant amount of time. And then we have an annual meeting for 2 days, generally, sometimes a field trip. So that's a lot of time when you build that up over 20 years. But that's been a key part of looking at the technical issues arising and how we address them. Are there potential new partners? They may be researchers, they may be other folks from industry, they may be equipment suppliers. We need to always be aware of having open doors for that as well. What are the outcomes of the research? What are the value of the findings? What are the applications and how have they been adopted? And then are there further opportunities for collaboration? So at each phase of this railway program, there's been a very open discussion about what have we discovered, what's still outstanding, and where might we go into the future? And that's a key part, again, of the sort of 20 years of success. In this case, another really essential component is professional support. So someone who serves as the secretariat. So the woman in the middle back is named Cindy Hicks, and she has been the secretariat for this organization the entire time and has really been the sort of heart and soul of keeping this running. So that's often overlooked, but that's a very important part of keeping everything moving forward. So measures of success. If we look at the left-hand side, when we write our grant applications, we're talking about how many people have we trained? Where are they working? Have there been patents? Have there been spin-off companies? How many papers have been published? Increasingly, we're being asked to talk about the breadth and depth of the collaborative support as well. So all measures of success from the perspective of the academic part of the partnership. But for everybody, the discussion on the right-hand side is a key part. What's happened to new ideas? Have they been jettisoned prematurely? Have they come through to fruition? Is there more work to be done? Most importantly, did our knowledge, our decision support, our approach change as a result? Did we find a new source of data? Did we collect more data? Do we have different data? Did we save money in the long run? Did we develop innovative solutions? Did we better optimize the engineering solution? So these to me are somewhat nebulous at times, but very important measures of success, which we need to keep bringing forward. So again, in our railway program each year, generally one of the railway or both of the railway representatives talk about how the research program has modified or affected or improved some of their processes. And that's a key part of measuring the success. A really important thing to keep in mind is, first and foremost, what's in it for the student. And that may seem kind of an academic consideration, but the student is the person who is devoting 2 to 4 years of their life to this particular program, probably largely underfunded, especially with the cost of living these days. And so what's in it for them? Are we getting them to photocopy stuff, or are we actually getting them to engage in a solid way in a collaborative research program? Are we giving them the best chance to develop and to learn and to innovate? The academic, so that's sort of, again, my perspective. Academics don't receive any funding at all from these collaborative research programs. If it's a contract, they may do, but in the grant situation, there's no funding. We work on our university salaries on these projects for free in Canada. And so what's in it for the academic? If they are prevented from publishing, that's a pretty significant component of what an academic is hoping to get out of these projects, along with all the collaboration. Absolutely, what's in it for the industry and government partner, and I'm sure everybody has their perspectives on that on this call. What's in it for the regulators, and what's in it for the industry as a whole? We have to also be careful on some of these collaborative programs that as new technologies develop and they're put out into the industry, how is the industry as a whole developing? And I think a case in point is truly the application of LiDAR. through the program. And Matt, who introduced me at the beginning, started his research many years ago with a brand new LiDAR system that we had just acquired. And I think for anybody who's familiar with Matt's work and BGC's work, adopting and using LiDAR, you can see the evolution over time. And I think it's improving the industry as a whole very significantly. What's the future of R&D collaboration? So absolutely data-driven decision-making. We can record so much more information. We can assess that using guided machine learning and AI. We can better predict outcomes and support decisions. So absolutely a key part of R&D collaborations going forward. I think going forward, a more formal development of some of the knowledge mobilization methods and assessment of effectiveness are required, especially from the funder's perspective. An increasingly important component is evaluation of participation of the recipient communities and impact on society of the research that we're doing. More formal measurements of return on investment. And again, that may be funding from industry, but it's also an enormous amount of time contributions from industry members. And so how much are you getting back from that return on investment? Requiring multiple technical perspectives in a team. For most people on this call, that's probably a given, but I started my career when there were many silos, and there are still lots of silos in academia. So we need to have these multiple technical perspectives. I mentioned earlier that we have a project looking at game engines and physics engines and how we can use those to model fragmental rockfalls. That comes from one of my research collaborators, Rob Harrop, who's very familiar with the world of computing and game engines and physics engines and how we can apply those. So that's a variety of technical perspectives. We also see, unfortunately, an increasing limitation on international collaborations. We see challenges with having students, international students, and limitations on funding them. And we see the new limitations on the collaborations on research that we can do internationally. So that's another future direction that we'll have to be aware of. So I just wanted to bring forward two other slides just to give a little technical content. This work is not mine. So I'm bringing this forward because this to me is a really interesting application of monitoring and understanding from a large slope instability. And many of you on the call may be familiar with this. This is an instability that occurred at Bingham Canyon Mine in 2021. And you can see on the left side and the right side the result of that instability. These pictures are from Serdar Ergun's talk in 2022, and so these images are all used with permission of folks at the mine. And so what they did in this case was they had videos of this instability. And if you look up here, you can see on the right-hand side, what's playing is a thermal camera view of that instability. And that was a collaborative research project at the time with the University of Arizona and with Chad Williams to look at the applications of thermal cameras for monitoring. And it happened to be situated there at this time and could capture this instability, which is 1,500 feet high. You can also see that post-processing has added some information about where on the various benches the failure affected it. On the left side is an image from a drone or a UAV that was flying over the instability. This is a really interesting case of being able to look at inverse velocity. And they predicted this instability within, I think, 23 minutes of when it occurred. So all of the tarps were in place, everybody was evacuated, and they had this UAV flying ready to capture this instability. And when I run the video on the left, you can see how the instability occurred. At this point of the screenshot, if you can, it's maybe hard to see, but just in the middle distance on the left side of this still from the video, you can actually see dust clouds from some precursor instabilities. But when I run this video, you'll see how this instability affected the top of the bench here. And if you look down to the bottom, 1,500 feet below, as this starts to go, you can see how the material moved. So in this case, this is a really good example in my mind of some of the new monitoring technologies and techniques, being able to gain much more information about what's happening and understand. And again, this was a collaborative program between University of Arizona and the mine site. This was then used to guide and calibrate some FLAC 3D modeling that was done by a task in collaboration with the folks at the mine. And if you're interested, there are a number of papers about this instability by Greg Abrams, Serta Ergon, other people. Again, if you're interested, I'm happy to give people some guidance on that. So I'd like to thank you very much for your attention today, and also thank BGC for the opportunity to give these remarks. Thank you very much.
Thank you so much, Jean, for joining us today. Awesome talk.
Thank you.
We do have to move on to the next one, but I do encourage folks to leave a comment in the chat, and if you want to follow up with Jean, we can make that connection as well.
Thanks very much. Sorry, I went a bit over time there, Matt.
No, that was perfect, Jean. Thank you very much, and I'll pass it over to Ian Stillwell now next to introduce our next speaker.